Sir,
Today we are here for the practical number 4, that is voltage regulator. Actually, this is the practical number 5, but as per the syllabus it is 4 because one of the session I have taken for the learning of multisim on multisim live. Okay. Uh, in the last practical, we have seen the current series feedback. So I just want from your side a feedback that uh, we completed all the calculations for the current series feedback in the last practical. Means transconductance gain with or without feedback, input resistance with or without feedback, or output resistance with and without feedback. Yes or no? Those who have attended the practical, current series feedback. Anyone remember? No reply. Okay. We would be continue the this practical explain number 4, voltage regulator. So the aim of our practical is to design and simulate an adjustable voltage regulator using 3-terminal regulator IC. Actually, we have to perform it on the hardware breadboard. So we will be also perform when you would become physically. But today we would be continue on the simulation. So the objective of our practical is first to design the circuit using LM317 adjustable voltage regulator for the given specification. Second, to calculate the minimum and maximum regulated output voltage. After implementing or conducting this practical, you would be able to first analyze and evaluate the performance of switching regulator towards the applications in regulated power supply, and second one, verify the practical values of output voltage and with the theoretical values. We would be verify this. And the list of equipment or component or software you can say here, we have to be required one IC, that is LM317. It is a 3-pin adjustable voltage regulator IC. Resistors, capacitors, step down transformer. Instead of that, you can use the power supply as well. Then diodes or rectifier IC are also available nowadays. SPDT switch, single pole double throw switch, and wires. And since we are conducting it on the software, so we have to be required a multi-sim software or any other simulation software. You can also use the PSpice and other circuit simulation softwares. So this is the circuit diagram that we have to be followed today. Already we have learned this on our theory. So LM317, it is a 3-pin adjustable voltage regulator. Everyone please note down this particular circuit diagram. Here I have shown like V in is there is no component has shown to generate the V in. So we would be see when we have to actually implement this circuit on the multi-sim or hardware. So still we have to be consider it is some input voltage and it is mentioned 28 volt maximum we have to provide here. And you know that LM317 IC, that is I have taken this diagram from the data sheet of LM317. So you can see the pin arrangement. First pin is basically for adjustment pin, and the second pin is for output voltage, and third number pin is for the input voltage. Okay, and heat sink is generally connected to the pin number 2, that is output terminal. So here you can see uh, this is the filter where we have to be the 0.1 microfarad. You can separately use the filter capacitor also. Sometimes even the filter or the rest of the component of the power supply is far away from the adjustable voltage regulator IC. At that time, we have to be use some parallel capacitor to decrease the fluctuations of the voltage. But here you can, we have not need of this arrangement, so directly we can say the filter IC capacitor. Now on the pin number 3, this is the input voltage is given. Pin number 1, there is adjustable pin where we have to be connected the terminals of the R1 and R2. R2 is the variable resistor that could be vary between 0 to 5K, and you can use here a pot to vary the resistor, and R1 is a fixed value of resistor 240 ohm. This is pin number 2, that is the output pin that is connected to the output terminal, and there is a one capacitor is also there to improve the transient response. So here first of all we have to see the basic theory of the power supply. So we start from this transformer. The input of the transformer is from the coming from the AC line, that is 220 to 240 volt AC, single phase AC is there, and here we would be use a step down transformer to step down the input voltage, input AC voltage, and the ratio of the turns from primary to secondary turns, it would be depend upon the output voltage we have desired. Okay, so according to that you have to be use the different step down transformers. The output of the step down transformer is again a sinusoidal signal, and this would be sent this would be given to the input of the rectifier circuit. Here we are going to use the bridge rectifier, that is a full wave rectifier actually. So output of the rectifier would be the pulsating DC, that would be further fed to the filter, which would be smoothen the pulsating nature of the DC signal, and it would be provide more smooth DC signal, and would be remove the ripples also present in the pulsating DC. Then the output of the filter is given to the regulator. Here we are using a adjustable voltage regulator IC LM317, and the output of the regulator would be a finally at a DC output voltage. Okay, and at the output of the regulator you can connect the load. This could be a resistive load or capacitive load you can connect. So these are the component descriptions that all we have already seen. So the block diagram, so I am not going to discuss. This is all transformer, rectifier, filter and regulator ICs. A voltage regulator is one of the most widely used electronic circuit in any device, and the regulated voltage, that is means a voltage which is free from the fluctuations and noise levels. It is a very important for smooth functioning of the many digital electronic devices. A common case is with the microcontrollers, where a smooth regulated input voltage must be supplied for the microcontroller function. So there are lots of the digital circuits we have to be required a stable or regulated DC voltage for smooth application. So we have, for that purpose we have also required a voltage regulators, and we know that voltage regulators are available of different types, and nowadays IC based regulators are very much popular. In the earlier days we have to use the Zener diodes for the regulation of the voltage, but nowadays IC voltage regulators are available. So an IC voltage regulator can be classified in different ways. Means it could be classified as per the terminal way numbers wise. Means 3 terminal voltage regulators are available, 5 terminal voltage regulators are available, or the multi-terminal IC voltage regulators are also available. Another way of classifying that, you can identify them as a linear regulator and switching voltage regulator like this. So if you were to be see broadly classify the voltage regulator, there's a 3 category. Actually the 2, linear and switching, but you can further classify the linear as a fixed voltage regulator and the adjustable voltage regulator. And then the third one is the switching regulators. So today we have to be learn about the adjustable voltage regulator. An adjustable voltage regulator is a kind of regulator whose regulated output can be varied over a range. Like today we are going to learn about the LM317. It is a positive adjustable voltage regulator and its output voltage can be varied over a range of 1.2 volt to 37 volts. So this is the range that we have to be. Similarly to LM317, there is a counterpart of this at LM337, that is the negative adjustable voltage regulator. So LM337 is actually a complement of LM317, which is similar in operation and design. Only difference of polarity is there. Now we have to see the description of the LM317. So LM317 having 3 pins: input, output and adjustment pin. If you have to see the structure of the LM317, so it is nothing but conceptually it is an op-amp, and it is having the high output current capacity. So the inverting input of the op-amp is adjustment pin, while the non-inverting input is set by the internal band gap reference, that is actually a stable value. We have already seen in the theory lecture, that is 1.25 volt. It is a fixed value. And apart from this, there is the 2 resistors R1 and R2 that is used to determine the output voltage. The resistor R2 is adjustable resistor and it can be adjusted to get the output voltage between the range 1.2 volt to 37 volts. And we have defined the equation that would be used for calculation of the output voltage, that is V out is equal to V reference into 1 plus R2 upon R1 plus I adjustment into R2. So this is the most important formula for overall discussion of this LM317 that you have to be remember for the solution of the numericals and the design of the voltage regulators. So in this circuit, the value of V reference is constant 1.25 volt, and the value of adjustment current I adjustment would be very small. Sometimes it would be also neglected. It is nearly 100 microampere. And if you would be neglect the effect of I adjustment, you can approximate the value of output voltage by writing this equation as V out is equal to V reference into 1 plus R2 upon R1, or 1.25 into 1 plus R2 upon R1. The load regulation is 0.1% and the line regulation is 0.01% per volt. It is as per the mention in the data sheet of the LM317. So line regulation is 0.01%, means you can say output voltage varies only 0.01% for each volt of the input voltage changes. The ripple rejection ratio is also the 80 dB for the LM317. Now we have to come to the design part. So we have to design a voltage regulator using IC317 for the output voltage 3 volt to 12 volt and output current I0 is 1 ampere maximum. So you can take any range in between 1.25 volt to 37 volt. Okay, so here I have taken minimum voltage as a 3 volt and maximum as a 12 volt. So for this given specification, we have to design our circuit. So first of all, we have to remember or recall our formula. V out is equal to V reference into 1 plus R2 upon R1 plus I adjustment to R2. We know that I adjustment is 100 microampere. So we have to here find out the unknown values. So V out is given, V reference we know that 1.25 volt, I adjustment is given, only we have to find out the R2 and R1. And here we have to assume that R1 is also a fixed value, that is 240 ohm. So only we have to find out the R2. So just substitute all the values given in the equation and you can easily find that the value of R2 for the minimum voltage 3 volt and for the maximum voltage 12 volt. So when you substitute all the values on the output voltage equation, so first case when the V0 is 3 volt, that is minimum voltage. So R2 minimum would be, if you would do the calculation, it would become 336 ohm. And when V0 is maximum, that is 12 volt, then what would be the value? Can anyone tell me? When V0 is equal to 12 volt, so what is the value of R2 max? You have 1 minute to calculate this. Anyone tell me what is the value would become when your V0 is 12 volt? Anyone has calculated? It means you have not attending the lecture, you have not keep the notebook or pen with you. Otherwise, it is a very simple mathematics. It is looking like that it is a one-way communication. I am only talking and you are just log on the Zoom ID and left out the class. Aditi Vakchore, what is the value of R2? Okay, time is very less. I'm not going to waste. So when V0 is equal to 12 volt, your R2 would be 2.06 kilo ohm. That is the maximum value of the resistor for the given specification. And here you can calculate the reference of R1, that is 1.25 upon 240, that is 5.2 milliampere. So according to our design, we have to select a potentiometer of 5K, that would be vary the value of the resistor from 330 ohm to 2K as per our design. Okay, actually the 336 ohm resistor is not available practically. We have to be select 330 ohm, and for the 2.06 kilo ohm we have to be select 2K resistor, or you can use a 5K pot. So first of all we have to be see the procedure, that is the design the circuit as per the given formula, implement the circuit according to the diagram, circuit diagram, and vary the R2 and measure the output voltage using multimeter and calculate the minimum and maximum output voltage. So here in the observation table I have written the theoretical value. We have to be find out the practical values. So I am going to share you the okay. So this is a multi-sim window. I have already drawn the circuit because it would take lots of time. You can draw this circuit. I am just saying that what are the important components. First of all, we have to be required a AC supply. So you have to be choose this symbol of AC supply from the component database, that is power sources. Go to the AC power and select OK. You would be get this AC power source, and here we have to be, by default it is written 120 volt RMS 60 hertz. You can convert into the 50 hertz as per our requirement, then 220 volt. Okay, and after this change you have to be use a transformer. Here I have taken 10:1. So you have to be go into the database of the component, select the group basic, select the transformer. Here the TS power 10:1 transformer, power transformer with the ratio of 10:1. Center tap transformer is there. So it would be decrease or step down the voltage 10 times. Okay. So the output of the transformer is again a AC signal. It is given to the one bridge rectifier. So this is IC number 3N246. Everyone note down this diagram and the IC numbers of each and every components or the value of the components. It would be available on the component database. Diodes, you have to select the group diodes. Go to the FWB, full wave bridge rectifier, select 3N246 IC, and you would be see this bridge rectifier, and the input terminal of the rectifier would be connected to the output of the transformer. It is a center tap, so center would be connected to the ground, and the another two terminal of the full wave rectifier is connected to the filter. Now we have to be connect a 100 nanofarad capacitor. Actually it is a 0.1 microfarad. So in the database it is not 0.1 microfarad is available, it is minimum 1 microfarad. So I have taken the nanofarad as a unit and converted according to the 0.1 microfarad 100 nanofarad capacitor. Then you have to select the LM317, that is also available on the in some multi-sim version. It is available in the mixed component, in some it is a power. Here the power is a voltage regulator. Here the ICs are available. Presently whatever the version I have taken here, it is not displaying LM317, it is displaying LM117. That is also equivalent to it. You can also select this 3 terminal adjustable voltage regulator. Okay, and in some version of the multisim it is available. You can also select this. So LM317AH. Okay. So this is one of the term is the input voltage. Then the common means adjustable, and V regulated means output terminal. Now we have to be calculate the 240 ohm resistor R1. Then I have also connected a SPDT switch, single pole double throw switch, for switching the resistor value between 330 ohm to 2K. In hardware practical, you can use a potentiometer to vary the value of the resistance of R2. Okay. And then further we have to be collect output capacitor of 10 microfarad, and finally across it we have connected the multimeter and adjust the multimeter in the voltage and the DC voltage range here. This is very important, do not select the AC. Then we have to be implement this circuitry. Now how the switch would be switched? It is here mentioned S1 is switch, and it is the key is space. So when you press the when you click on the switch and press the space, it would be switch from one terminal to the another terminal, means from the terminal 2K to the 330 ohm resistor. So now you do the simulation, start the simulation. Now the R2 is 330 ohm. You can see the output voltage is 2.94 volt. This is the output voltage when your R2 is 330 ohm. It is nearly 3 volt. So 2.94 volt. Now we have to see what happens when you have to be switch from 330 ohm to the 2K resistor. You can see your output voltage would be also change from 2.94 volt to the 11.51 volt. It is nearly to the 12 volt. So in this way we have seen that practical value of the output voltage would be nearly similar to the theoretical value of the output voltage when you vary the R2 from 330 ohm to 2K. Okay. So everyone please take the screenshot of this. Now we have to be switch to the again to the PPT. And fill up this observation table. That would be you can see here 2.94 volt and here 11.51 volt. And why these changes has came? Because we have changed the value of R2 from 336 ohm to the 330 ohm and 2.06 kilo ohm to the 2 kilo ohm. So as the practical availability of the resistor, we have changed this value and we have got the change in the output voltage also. Now we have to find out these two values and output value of the voltage according to our design. Now we have to be just conclude this practical that we have achieved our objectives. First of all, we have designed the adjustable voltage regulator for the given specification from 3 volt to 12 volt output, and then we have verified the theoretical value with the practical one, and we have found that it is nearly same. So in this way we can say that we have achieved our outcome. And now I would be show you the references used for this particular practical is, that is, everyone please start to fill the attendance on the chat box. So these books you can refer, David A. Bell, Electronic Device and Circuits for fifth edition, Oxford Press. It is very good book for designing of this. Then the data sheet of LM317, and either you can refer the Talwar Sontak book, Electronic Circuit Design. That is also a very good book for the power supply design. Okay. So I hope all of you understood this particular practical. If anyone has any doubt, you can ask me.